Okay, so students, we're discussing about the design of a circular slab, okay, with the simply supported ends. Okay, so now, okay, so this is what we are doing, right? So we have to find out the depth of the section. After that, we find out all the bending moment, and using the bending moment, we did the reinforcement details of the circular slab. Okay. So for the circular slab, we are giving the reinforcement two patterns. First, how you are giving? First one is for the central portion, that is in the mesh form. Next is in the edge. Edge, how you are giving? Circumferential and radial. Okay. For the edge portion, we are giving the reinforcement in the with the circumferential and radial portion. So the total circumferential radial reinforcement, we got it as 280 mm square. Okay, that is the edge. Edges provided the reinforcement is 280 mm square. So we are using 10 mm diameter bar. Now 10 mm diameter bar has to be provided as a radial reinforcement. Okay. So radial reinforcement that is provided that is this one. If you seeing in this figure, so this is a radial reinforcement. See. So this is a development of length. Okay. So radial reinforcement that is extra length provided in choosing, you have to take the development of length. So development of length is 56.5. Okay. So 56 into diameter of the bar. Okay. So at length. So we are getting it approximately 5060 mm. Sorry, 560 mm. 560 mm round is 600 and you are providing it as a radial reinforcement. Okay. So this is how you are providing reinforcement. Okay. Okay, so all of you please write down this sentence. Okay. So development of length LD is equal to 56.5, that is 56 into diameter, that is 550. 560 you are rounding it to 600 mm. Okay. Now number of rings that is recorded, total circumferential moment. Okay. Total circumferential moment divided by area of one reinforcement bar. Okay. So reinforcement bar 10 mm diameter bar area 5 by 4 into d square, that is 78.5. Okay. So approximately you will get a 4. So you can write a note like provide 4 rings in a width of 2 by 3 into 560 mm. So you can provide four numbers of 10 diameter circular rings at 125 center to center from the edges. Okay. So that is, you can see in this figure. So see this is, see this. Okay. So നാലെണ്ണം. So you can see four numbers of 10 diameter bars has been provided here. See. Okay. And this is at a width of 2 by 3 into 5 by 60. അതായത് ഈ രണ്ട് റിംഗ് തമ്മിലുള്ള ഡിസ്റ്റൻസ് ആണ് 2 by 3 into 560 ആയിട്ട് എടുത്തിട്ടുള്ളത്. Okay. അതായത് ഈ റിംഗ്സ് തമ്മിലുള്ള ഡിസ്റ്റൻസ് 2 by 3 into 560 mm. So you can write it like four numbers of 10 diameter bars. Okay. And this is a central reinforcement. Okay. Central reinforcement that you are providing as a mesh, that is 10 diameter at the 180 mm center to center in the both direction. Okay. Both horizontal and vertical direction. At the center portion, you are providing reinforcement as a mesh. That also you can see here. Okay. Next is we will see how the radial reinforcement is provided. Okay. So the radial reinforcement. So that is 560. We got 560 rounding up to 600. Now we need to see at what distance, that distance between these two reinforcements, how much it is. Okay. എത്ര ഡിസ്റ്റൻസിലാണ് റേഡിയൽ റീൻഫോഴ്സ്മെന്റ് കൊടുക്കുന്നത് എന്ന് നമ്മൾ അറിയണം. Okay. That is distance between this radial reinforcement. Okay. So how we will take that? Okay. That is okay. So that is, see here, the spacing required is 3 times that of center. So how we are providing reinforcement for the radial reinforcement is that 3 times the reinforcement that you have provided at the center. നമ്മൾ സെൻറ്ററിൽ കൊടുത്ത റീൻഫോഴ്സ്മെൻറ്റിന് 3 ഇരട്ടി ഡിസ്റ്റൻസ് ആണ് റേഡിയൽ റീൻഫോഴ്സ്മെൻറ്റിൻ്റെ ഡിസ്റ്റൻസ് ആയിട്ട് കൊടുക്കുന്നത് അല്ലെങ്കിൽ സ്പേസിംഗ് ആയിട്ട് കൊടുക്കുന്നത്. Okay. So for the central portion you have provided reinforcement of 180 into 3 you will get a 540. Okay. So 540 we know that we cannot accept a value which is more than 300. Okay. IS could always restrict the spacing value to 300 mm. Okay. So if it is a distribution bus, it is 450 mm, and if it is a main bus, it is 300 mm. Okay. We cannot provide a spacing which is more than 300 mm. Okay. So as of this is a slab portion. Okay. This is a slab. So here we are having main bus. എല്ലാ main bus ആണ്. നമുക്ക് distribution bus എന്നൊരു സംഭവം ഇവിടെ വരുന്നില്ല. As of the slab is concerned, you are providing main bus. Okay. So you have to take 3 times the diameter of the bar, that is 540, which is greater than 300. So limit the value to 300 mm. Okay. So you have to limit the value to 300 mm and write a note like this. Providing 10 mm diameter bars at 300 mm center to center radially for a distance of 600 mm. Okay. So this is it. Rather, if you see the correct 3D of this picture, you can see, okay, this is the 3D of the radial reinforcement. Okay. So radial reinforcement, this is the 600 mm. Okay. So this is here 600 mm. the distance between these two bars. Okay, distance between these two bars is 300 mm. Okay. So this is the pattern we will be providing the radial reinforcement. Okay. So radial reinforcement are to a distance of 600 mm, that is at 300 mm center to center along the periphery. So that's what they have written here. Okay, don't care about the support, negative moment and positive moment, that is not required. You can just write down this. Okay, provide along diameter bars at 300 mm center to center radially for a distance of 600 mm. Okay, write down. Okay. Okay, now coming to the last step, that is you have to check for the shear. Okay, for checking the shear, you will be needing IS 456. Okay, now let's see. Critical shear for the critical section for the shear is at a distance of D from the support. Okay, so always you can say that the critical section always occurs at a distance of D from the support. Okay, so this you can note. Okay. So the critical section occurs at a distance of supporting the D എന്നുള്ള ഡിസ്റ്റൻസിലായിരിക്കും you will be having maximum shear force. Okay. അപ്പോൾ ആ ഒരു സെക്ഷൻ അതായത് സപ്പോർട്ടിന്റെ ഡി എന്നുള്ള ആ ഒരു പോർഷനിൽ എത്രയാണ് ഷിയർ ഫോഴ്സ് വിൽ കാൽക്കുലേറ്റ്. Okay. So first of all we need to know what is the distance D. Okay. How much is this D we need to know. Okay. So R is equal to 2500 minus 90. Okay. Okay. So 90 means how much? 90 ആണ് എന്ത്? 90 ആണ് നമ്മുടെ D എന്ന് പറയുന്നത്. D means what? Okay. So I'll tell you. Okay. See this. This is the effective set. Okay. So this is the effect. Sorry. This is the overall depth of the slab. Slabന്റെ മൊത്തത്തിലുള്ള depth നമ്മൾ എത്ര എടുത്ത് 120 ആണ് എടുത്തത്. Okay. So 120 that is overall depth. So to get the effective depth D, you have to deduct the cover. Cover you took it as 30 mm. 30 mm ആണ് cover it. So 120 minus 30, you will get it as 90 mm. Okay. So 90 is your effective depth. Okay. 90 is your effective depth. So you can write down D is equal to 120 minus 30. That is overall depth minus cover. That is 90 mm. Okay. Okay. Next. Uh, we have to find out the shear force. Shear force in the equation, the maximum shear force in the equation. That is W R by 2. Okay, this is the equation for the shear force. That is W R by 2. So here W means how much? Load, factored load. Okay, factored load is 10.5 kilonewton per meter square. നമ്മൾ തുടക്കത്തിൽ കണ്ടുപിടിച്ചാണ്. Next is R. Okay, R is the radius of the circular slab. So that R is there. How much is the R? Okay, so R, that is radius of the circular slab. Total radius of the circular slab, you are taking it as R. Okay. Okay. Anyway, what we are actually calculating here? Here we are calculating the shear at the critical section. Critical section ulla shear aanu nammal calculate cheythu. Okay. So where is the critical section? Critical section is at a distance of D from the support. Okay. Support in a D enna distance lana critical section kidakunnu. Okay. So we need to find out the shear force at the critical section. Okay. But maybe assume that. Okay. So you can assume this point. Okay. You can take this point. So this is the point where you are having the maximum shear force, or you can say this is the point where we are having critical section. So each section will be at a distance of D from the support. This is support. Okay. This is the support. Okay. As the slab is concerned, then another support. This support in it at a distance of D, you are having maximum shear force. Okay. So here you have to calculate the shear force at the critical section. Okay. So critical section here you are having critical section. Okay. So here radius R means this is the R. Okay. Critical section distance here we are taking it as a small r. Okay. Maximum shear force our distance and we are taking it as small r. So that is R is equal to 2500 is the radius of the circular slab minus D. D is 90 mm. So you will get 2410 mm. So you can say that if this is a circular slab, okay, if this is a circular slab at a distance of 2410, you are having maximum shear force, or you can say you are having maximum critical section this point. Okay, this will be the radius of the circular slab. Okay, so this is the point you are having maximum shear force. So this point stress and shear stress we have to calculate. So R we got as 2410. So don't get confused with that. How you got R it like this? Okay. Okay. Every critical section we detected depth from the total radius. Okay. So R is equal to 2500 minus 90, that is 2410. You can substitute in this equation. So here R is equal to 2.41, that is converting the mm into meters divided by 2. So you will get as 12.65 kilonewton per meter. Okay. So shear force you will get it as 12.65 kilonewton meter. Now once you got this, next is you can find out the nominal shear stress. Okay, this is the nominal shear stress. Nominal shear stress is VU divided by B into D. Nominal shear stress is VU divided by B into D. So that is 12.65 into 10 raised to 3, that is to convert into Newton, divided by B. Remember, it's a slab section. So always you're taking it for a unit root. So B is equal to 1000, D is equal to 90. We got it 90. Okay. So nominal shear stress is 0.14 Newton per mm square. Okay, write it down. Okay, ഇപ്പൊ തന്നെ എഴുതിയെടുത്ത് പോയാൽ പിന്നീടാകുമ്പോൾ കൺഫ്യൂഷൻ ആവും. പറയുന്നതിനൊപ്പം തന്നെ കുറച്ച് സ്പീഡിൽ എഴുതുക. So shear stress is equal to 0.14 Newton per mm square. Nominal shear stress is equal to 0.14 Newton per mm square. Okay. So next is you have to find out whether this shear stress developed is within the limit or not. Okay. So IS 456 IS 456 is recommending certain shear stress values. Okay. So based on that shear stress value, we have to see whether our shear stress is within the limit or not. നമുക്ക് കിട്ടിയ shear stress permissible ആണോ അല്ലയോ അല്ലെങ്കിൽ IS code recommend ചെയ്ത പ്രകാരം is it within the limit or not? That is what you have to find out. Okay. So for that, you have to refer IS code page number 73. IS 456 page number 73, same page. Okay. So if you are having that, so if you are seeing that IS code, you can see that IS code എങ്ങനെയാണ് shear stress തരുന്നത്? That is based on the percentage of reinforcement ratio. Okay. IS 456 page number 73 nate, based on the reinforcement ratio, they have given the shear stress. Okay. So here first you need to find out percentage of reinforcement ratio. Okay. Percentage of reinforcement ratio എത്ര എന്നാണ് കാരണം IS കോഡിൽ percentage of reinforcement ratio പ്രകാരമാണ് shear stress തന്നിട്ടുള്ളത്. Okay. So we'll find out the percentage of reinforcement ratio. So നമുക്ക് എന്താ ഉള്ളത്? Percentage of reinforcement ratio. So what is the equation of percentage of reinforcement ratio? That is CT is equal to how much it is? Okay. The IS code page number 73 now the equation has been written as percentage of reinforcement ratio is equal to 100 AST divided by B into D. Okay. 100 AST divided by B into D. So here AST, how much it is we have to find out. B we know that is 1000. D is also we know. D is equal to 90. B is equal to 1000. Okay. So this AST this AST has to be AST provided. നമ്മൾ സ്ലാബിൽ പ്രൊവൈഡ് ചെയ്ത AST വേണം നമുക്ക് എടുക്കാൻ. Okay. സ്ലാബിൽ എത്രയാണോ AST പ്രൊവൈഡ് ചെയ്തത് ആ AST വെച്ചിട്ട് വേണം നമുക്ക് പെർസെൻറ്റേജ് ഓഫ് റീഇൻഫോഴ്സ്മെന്റ് റേഷ്യോ കണ്ടിരിക്കാൻ. So how much AST we have provided? Let's see. Okay, actual that is provided. Okay. Okay. So here we are having two types of reinforcement. On the central mesh next one is for the circumferential edges. So here we are considering the central reinforcement. Okay. Okay. To find out the AST provided, we are considering the central reinforcement. Why? Because central reinforcement is occupying the major reinforcement of the circular slab. Okay. If you have a circular slab, you can see the major reinforcement will be occupied by the central portion. Okay. So we are taking the central reinforcement as the major reinforcement, or we can say the central reinforcement we are considering to find out the AST provided. Okay. So how much is the central reinforcement? See, centrally we provided that is 420 mm square. Okay. So here you can see we provided 420 mm square. So 420 mm square, that is as per the equation, right? See, this is AST required. Okay, as per this equation, AST required is 420 mm square. But the equation demanding the 420 mm square. But we don't know whether we have provided that much or not. എത്ര നമ്മൾ പ്രൊവൈഡ് ചെയ്ത് നമുക്കറിയില്ല. So what will you do? The same thing. But we know that we have provided 10 mm diameter bars at 180 mm center to center. That we have provided. നമ്മൾ പ്രൊവൈഡ് ചെയ്തത് എന്താ? We have provided 10 mm diameter bars at 180 mm center to center. That we have provided. Okay. So based on this is a true value. Okay. This is actually a true value that is we are going to do at the site. 420 mm square എന്ന് പറഞ്ഞാൽ equation in the round ചെയ്തിട്ടുള്ള value. We don't know whether we'll be able to provide that the site or not. Okay. So we have to find out the AST provided. So AST provided എന്ന് പറയുമ്പോൾ എത്ര വരുന്നത്? So AST provided is equal to, okay. So spacing in equation, you can take spacing equation. Spacing is equal to 1000 A5 divided by AST. Okay, 1000 A5 divided by AST. Okay. So in this equation, spacing. Okay. So we will rearrange this equation and you will find out AST. Okay. It you can take cross multiply area, and that is 1000 A5 divided by spacing. 1000 A5 divided by spacing. Okay. So 1000 into A5 area of 1 bar, that is 78.5. That is we have provided 10 mm diameter bars. Okay. That is 10 mm diameter bar provided. 10 mm diameter bar area that is 78.5 mm square. Okay. Spacing, how much we have provided spacing? 180 mm. Okay. So 180 mm. Okay, so this is actually a true data. Okay, 10 mm diameter bar 180 mm center to center that is a true data. Okay, so based on this true data, you will find out AST provided. എത്രയാണ് ശരിക്കും സൈറ്റിൽ കൊടുക്കുന്നുള്ളത്. ഓക്കെ, ഈ 420 mm as per the equation that we will never be able to provide the site. Okay, അപ്പോൾ നമ്മൾ കറക്റ്റ് ലെങ്ത് എത്രയാണ് കൊടുക്കാൻ പറ്റുന്നത് നോക്കാം. ഓക്കെ, so if you are providing 10 mm diameter bars at 180 mm center to center, how much will be the AST provided? You can find it like this. Okay, so AST provided is equal to 1000 A5 divided by spacing, that is 1000 into 78.5 divided by 180. So how much you are getting AST? So AST you will get it as around 436 mm square. See the difference. Okay, you will get it as 436 mm square. Okay, so if the equation it is 420, but slightly ശരിക്കും എത്ര കൊടുത്തു വരുമ്പോൾ അത് 436 mm square വരെ എത്തും. So this is the actual reinforcement that we have provided. Okay. Now based on this, find out the percentage of reinforcement ratio. That is 100 AST divided by B into D. 100 into AST എന്ന് പറയുമ്പോൾ 436 divided by B into D. So you will get the percentage of reinforcement ratio as 0.48. Okay, 0.48. Now, what you have to do? Now you have to take the IS code, page number 73. So എല്ലാവരും പെട്ടെന്ന് എടുത്തേ IS code, page number 76, 73. And find out the shear stress. How much you getting? See, this is the table. Okay, can you see my table now? Okay, can you see my table? So from this table, how much is the reinforcement ratio? Reinforcement ratio is around 0.48. So that is, it will lie between, this is a C, the first column. Okay, this is IS code page number 73, page number 73, table 19. So this is design shear strength of the concrete. Okay, so from this table you have to find out the shear stress. Okay, so this is very easy. We have been doing this for the last semester. Okay, just to revise it immediately. So 0.48 means that will lie between 0.25 and 0.5, as you can see. Okay, 0.25 and 0.5 value area. So correspondingly we are having M20 value. M20 value is 0.25 corresponding at that is 0.36, as you can see. 0.5 corresponding at that is 0.48. Okay, so the maximum shear strength as per the IS 456, or you can say the permissible shear strength as per the IS 456 will lie between 0.36 and 0.48. Okay, then 0.48 is താഴെയായിരിക്കും. Okay, can you see? Okay, this is the 0.48. Okay, okay, അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ so approximately you will get as 0.47 Newton per mm square. Okay, maximum shear stress is 0.47 Newton per mm square from that table. Okay, okay, എത്ര 0.47 Newton per mm square വരും. Okay, so നമ്മുടെ okay, so that is you can see from this figure. So this is the last step. Okay, so you can say that permissible reinforcement, permissible shear stress as per the IS 456 corresponding to 0.48 percentage is 0.47 Newton per mm square. Okay, നമ്മുടെ സ്ലാബിൽ എത്ര ഡെവലപ്പ് ചെയ്തിരിക്കുന്നത് നോക്കൂ, ദാറ്റ് ഇസ് 0.41 ന്യൂട്ടൺ പെർ എം സ്ക്വയർ. സേഫ് റൈറ്റ് അല്ലേ? 0.41 നമ്മുടെ സ്ലാബിൽ വന്നിട്ടുള്ളൂ. നമുക്ക് എത്ര സ്ട്രെങ്ത് ഉണ്ട്? 0.47 റെസിസ്റ്റ് ചെയ്യാനുള്ള സ്ട്രെങ്ത് നമ്മുടെ സ്ലാബിനുണ്ട്, വിച്ച് മീൻസ് ദ സ്ലാബ് ഇസ് സേഫ് ഇൻ ഷിയർ. Okay, so you can write a note as the slab is safe in shear. Okay, so please understand the concept. Okay, the shear stress that has developed in the slab is 0.14 Newton per mm square. Okay, നമുക്ക് നമ്മുടെ സ്ലാബിന് 0.47 ന്യൂട്ടൺ പെർ എം എം സ്ക്വയർ വരെ സ്ട്രെസ് റെസിസ്റ്റ് ചെയ്യാനുള്ള കപ്പാസിറ്റി ഉണ്ട്. ഓക്കെ, സോ വി ആർ ഓൺ ദ സേഫ് സൈഡ്. Okay, so that's the end of the problem. And next is we have to draw the reinforcement details. So already നിങ്ങൾ വരച്ചിട്ടുണ്ടാവും. And also you should take a section here. Okay, ഒരു section exercise എടുക്കുക. Okay, draw the section. So the section, it will look like this. Okay, so you can just post your names to mark the attendance. Draw this figure. Okay, draw this figure and post your name to mark the attendance.